Okay, Unit 3 is electrochemistry. There's going to be a couple of things that are a little bit tough in here. I'm going to try and talk you through those. Electrochemistry is based on what we call redox reactions. So these always occur together. So you need a reduction and an oxidation. A reduction is a gain of electrons, and that's a gain of energy. And an oxidation is a loss of electrons or loss of energy. The word oxidation came from biting into an apple, literally. So if you bite into an apple and you let it sit there and it starts to turn brown, what happens is it's decomposing, it's oxidizing, it's a loss of electrons. Same thing happens with your car if it starts to rust. That's an oxidation reaction. Remember, these things always occur together. Now, when I give you a test in this section, what I'm going to try and do is take out some of the areas that are a little bit hanky. And some of this, you have to have some real background to understand what's going on. I'll explain what I mean. So, if something is a metal, it's on its own, magnesium solid, it has a charge of 0. If something is attached to something else and it's aqueous, we break it apart. We have one Cu, we have one SO4. Then if you do your reverse crossovers, you imagine there's a 1 there. The SO4 comes second, so we always said the thing that came second had a negative charge, 1 negative. The thing that came first has a 1 plus charge. Now here's where we run into a problem. This is not right. What you have to know is that SO4 has a 2 negative charge. So what you're going to have to do is you're going to have some type of chart that has things called polyatomics, and you're going to have to look up their charges. So the polyatomic SO4 has a 2 negative charge. And what this means is it's a 1-to-1 ratio. So if this is 2 negative, this is 2 positive. What I'll do on the test is to make sure that if you do this crossover rule, you'll get the right charges. So this is a little confusing, I get that. Cu solid is 0. Mg to SO4 is a 1-to-1 ratio. The one up here is 1 plus, the one down here is 1 negative, but a polyatomic chart would tell you that SO4 is always 2 negative, and because these are 1-to-1 ratio, this is 2 positive. I know, that's terribly confusing. I apologize for that. The examples I give you will be clear. Cross out what's on either side. So what we have is Mg0 plus Cu2 plus gives Cu0 and Mg2 plus. If you go from the Cu2 plus to the Cu0 on this side, that number is going down. 2 plus to 0 is going down. That's oxidized. Mg0 to Mg2 plus is, whoops, did I do that wrong? Yeah, Cu2 plus down to Cu0 is reduced. It's going down, not up. Reduced. Mg0 to Mg2 plus is going up. That's oxidized. Let's do one more example. If it's a solid, it's automatically a 0. If it's aqueous, we break it up. We have 2 Cls. We have 1 Mg. Our charge is Mg2 plus. So this 2 tells us two things. It tells us how many Cls we have, and it tells us the charge on the Mg. The charge on the Cl is 1 minus. Let's go over here. Lithium is 0. If it's a metal and it's on its own, it's always 0. KCl is K1 plus Cl1 negative. Now, what we have to do is we have to balance this, and I'll always give you balanced reactions. Because we have a 2 there, we have a 2 here, and we have a 2 there. I will give you balanced reactions on tests. 2Cl crosses out, 2Cl crosses out. We've got 2K going to 2K1 plus. Now, I'm going to tell you, the numbers out front will do nothing for you in these questions. You just look at the charges. 0 to 1 plus, that's going up, that's oxidized. Mg2 plus, the Li is supposed to be an Mg, sorry about that. Mg2 plus to Mg0 is reduced, it's going down. In these reactions, something will always be going up, something will always be going down. Let's look at a question without all of the mess. If something's a solid on its own, it's a 0. We have an Ag1 plus, a Cu2 plus. We don't care about the numbers out front. They don't change anything. All we do is look at the charges. This one is being reduced. This one is being oxidized. Number is going down, 1 to 0. Number is going down, number is going up, 0 to 2 plus. These are the important points from U3A1. Be aware it can get confusing when we have a situation like this, when you don't know what the numbers are, because this is a 1-to-1 ratio. You would think this is 1 plus and 1 minus. It's not. You'll have to look up the charge on the second part right here with a polyatomic chart. Hope this helped.